All right. Hey, everyone. Thank you so much for joining us for day 7 of Intermediate Advanced Programming Camp from Bay Tutors.
We are excited to have you guys here with us today, and we do have some material prepared for you guys.
Yeah, so we're going to go over our agenda right now. So let's start that right now. Okay, so our agenda for today, we're going to start off with array and array.
Just real quick, we can't see your screen right now.
Oh, you cannot. Oh, my bad. I'm sorry.
Yeah.
All right, there we go.
Yeah, we're good now.
I can see my screen.
We're good.
Cool. All right, so we're going to start off with arrays and array list review. And then we're going to move on to 2D arrays in Java, and then learning how to traverse those 2D arrays. And then finally, today we're going to get you guys started on your first sorting algorithm called bubble sort. So the first thing is what Anna's going to talk about, which is a review of arrays and array lists from what we covered on day 6 on Monday.
Yeah, so this is just a really brief review of what we covered on Monday. So really quickly, let's just compare both arrays and array lists, and both of them are essentially a list in Java where we can store a list of data, of variables, and then for comparing them, arrays are basically just a list in Java that are a fixed size. You can only store primitive, or you can store primitive and objects in them, but you're only allowed to store one data type, so you can't have a string and an integer and an array. You can only have one data type inside. For calculating the size of an array, we use the .length method. And then for referring to we refer to the index to add or set elements. So for example, we'd say the name of the array, and then in square brackets, we'd say the index equals to the value. So that's just how we would set or add an element. And finally, we can actually simply just add all of the elements in one step with the shortcut that we talked about in the previous session, where we just have everything set out in the list separated by commas in a curly bracket notation. So that's arrays. And again, we can look at the API. If you want to look at the API, you can look at some more of the methods that it has. But moving on to array lists are different because they're expandable in size. So although you can set it to a size at the start when you're initializing and constructing it, you can actually continue to change the size later on, and it's expandable in that sense. An array list only store objects, so you can't actually store a primitive data type such as an integer or a double, but you can simply use the wrapper classes like the integer class or the double class to store variables in it. And then, yeah, so they only store one data type as array lists do. And we can use the .size method to calculate the size. And for adding or setting elements, we can use the .add or .set methods. And finally, to manually fill, we have to manually fill the list unless we utilize some sort of loop to make that process shorter. But that's just a quick review of arrays and array lists. So we can, unless anyone has any questions or anything to add, we can move on.
Yeah, so adding on, so we talked about arrays and array lists and about traversing them. In arrays in Java, generally we use for loops to traverse an array, right? Starting at index 0, and then our limit will usually be the length of the array, not including the full length. So suppose the array is of size 6, we know that the array's index goes up to 5, right? So if we just make the index less than 6, then we just go up from 0 to 5. So that's how we would traverse arrays in Java. For array lists, more generally, we use for each loops because they allow us to, individually specify an object within that list. So that's sort of how the syntax for it also is. So it's sort of for object in this list. That's how you sort of write the syntax, and it's very I would say minimal when you compare that to a normal for loop, and it's very effective when traversing array lists in Java. So now we'll be talking about 2D arrays in Java. So recently we talked about arrays and how arrays are one-dimensional, right? There's in one line how we have arrays, but there's also something called a two-dimensional array. And if you look at the example on the right, it might look something to you like a table, right? And that's essentially what a two-dimensional array is. In programming, there are some situations, right, in which that the situation might call for using a two-dimensional array. And these situations, are more commonly used in like image processing. So if you were to look at, the diagram on the right, it's sort of similar to how an image would look. Assuming that's a 3x3 image. So images that have pixel values, right? And the thing on the right, this diagram, you could assume this is a 3x3 pixel image. So each little cell is its own pixel and that has its own value. For example, the value is between 0 and 255, if you'd like to know that. So it's like 10, 6, 15, 32, 46, 3. Assume those are all pixel values within this image, right? And together they construct one image. So that's one example of how two-dimensional arrays are used, because they are basically used to construct, right, an image, and you can also utilize them to process images, apply filters by, manipulating, changing these values. If you change the values and manipulate them, you can add filters to your image and so on. So that's sort of how two-dimensional arrays are used, specifically in Java. I know there are certain stuff like Greenfoot and BlueJ, which you can also use for image processing. So those are some really great tools if you'd like to check them out, where you can implement image processing using two-dimensional arrays. Yeah, so just in general, they are called as an array of arrays. And it's often easier to picture it with a visual, right, on the right. And they have two attributes, as you can see. They have a row and a column attribute. So the row, right, is the row, right, the horizontal thing, and the column is the vertical. And when these two attributes are combined, they form a grid, or like a table, as you can see. And each cell in that grid, right, has its own coordinate. So for example, if you look at the 0, 0, that refers to the first cell in the top left corner. So the 0, 0, so the 0th row, right? So the 0th row and the 0th column, they refer to 10. So 10 is the value. So if you were to call this down here, if you look at the bottom left corner where it says array of 0, 0, we'll go into this notation in the next slide, but just a quick overview. 0, 0, this will refer to the first cell in the top left corner, which would give you 10. That's sort of how you would use this. And I know the row is on top over here in the columns on the side, but this is to give you like a general orientation of what rows and columns are like. But actually, this 0 over here corresponds to this row, and this 0 over here corresponds to this column, just to make that clear. So this is the 0th row, this is the 0th column. Yeah, so again, some more examples. Maps are two-dimensional. Computer-generated images are two-dimensional, if they talked about how images have pixel values, right? That's how you can sort of emulate this. And yeah, so now going more on into the syntax, right, of how these two-dimensional arrays are created, you would initialize, right, a two-dimensional array. Sorry, you would declare a two-dimensional array like this, right? Suppose we had a map, right, as our array. Let's say that's the name of our array. We say int, right, or string, or whatever it is that we want to store in that array. We'd say that. Then we'd follow that with two closed square brackets, right? Two closed square brackets, and then the name of our thing. If you want to initialize it, then we do the same thing, right? The data type int, two closed square brackets, followed by the name equals new, the new keyword, int, right? The data type, followed by 4 and 5. So now the first subscript, right? The 4 here, that indicates the number of rows, and the 5 indicates the number of columns. So if you were to run this code, right, this table statement, you just run it, it would create a two-dimensional array like this, right? With okay, sorry, this is okay. It should be the other way around. This should be like flipped horizontally. So this is actually a 5 by 4, right? This is 5 rows by 4 columns. So if you were to do this, right, I think this would be a little bit better, right? So, right. So this would create something like this, right? So it'd have 5 rows, right? 1, 2, 3, 4, 5, right? 5 rows, and then 4 columns. So that's sort of how you would create a two-dimensional array. So it's by using the syntax. So once again, you have these two square brackets because you want to refer to the row and column, the row and the column. So that's sort of how you would declare one in here. And obviously the methods are basically the same, right? You'd use and once again, you cannot add to it. Once you create it, it's fixed because it's an array. Yeah, so that's something to keep in mind. And obviously, if you'd like to populate this, right, add your own numbers, then you'd have to say, well, you'd have to go through each individual cell and populate it accordingly. Yeah, but like, however, there is a way that you can populate it through initialization, right, which is not demonstrated here because it's not a very conventional way of doing it. How you do that is like similar to how we talked about in the previous lesson of how you can create an array, right, a one-dimensional array by saying the int array followed by curly braces, right, followed by curly braces plus all your numbers. Similarly, with two-dimensional arrays, you do the same thing, right? Except it would look a little bit something like this. So if we go back, we have someone. Okay, never mind. Okay, so it would look something like this. So instead of having it, another way of doing it would be like this. You'd have int, double array, table. You could do something like this. So you'd create two curly braces, and within these curly braces, you would create your individual columns. You'd say, like, maybe if you want to, your numbers, right? So you can have path like 2, 5, 4, 2, 5, 3, 4, right? Close that off, and then create a second one like 5, 4, 6, 2, and so on, right? This is another way of doing it. So what this would do is it would create a 2D array, right? It has 2 rows and 4 columns, as you can see. So these curly braces here, so these square brackets here, they account for a row. So this would be the 2, 5, 3, 4. This would be in the first row. Then 5, 4, 6 would be in the second row. And that would basically allow you to have 2 rows, right, with 4 columns because there's 4 numbers in each thing. That's another way of doing it, but this is not a very conventional way. It's not like very much used. That's why we didn't include it. But in the case you'd like to do that, that's one way of initializing your array. So now we'll be going over how to traverse, right? How do we, we can create these arrays, but how do we go through them, right? How do we populate them manually? How do we access each individual cell? That's what we'll be going through right now. So we have to be able to traverse, right, a 2D array. We have to be able to go through the row as well as the column to be able to access each individual cell, right? So we have to be able to account for both the row and the column, right? With the one-dimensional array, you only have one row and like however many columns, right? But with the two-dimensional array, you have multiple rows and how many ever columns. So you have to be able to access each individual one of them. So yeah, and as you can see here, this is an unconventional way of initializing a 2D array, as I mentioned over here. So the length of the 2D array, right? If we're talking the length of the 2D array, so you know how with 1D arrays we have a dot length method. If you call that same dot length method on a 2D array, it'll return you the number of rows it has. So for example, if you look here, if I were to call the dot length on this array over here, right? It would give me 1, 2, 3. It'd give me 5. The length of this array would be 5 because it would return me the number of rows that are there. Since we have 5 rows here, the length of the array would be 5. And that's great, right? So that helps build our first segment of traversing. Then the next thing is that, so that gives you the number of rows, right? So if you want to see, okay, how many rows are in my 2D array, you just call dot length, since that will give you the number of rows. Well, what if you want to find how many columns there are? To find the number of columns, you would say, give me table of 0, right? Or array of 0 dot length. And what the of 0 does is it's referring to the 0th row or the first row. We just pick the 0th row because like that's the beginning of the thing. It doesn't really matter. You can pass in 1, 2, or however many rows you have in here, but 0th row is just more conventionally used because it's the first row. And what table of 0 dot length gives you is it'll give you the length of the first row, which is the number of columns, right? If you look here, this is the first row, right? The 0th index is the first row. Now, if you say, what is the length of this first row? It'll give you 1, 2, 3. And that's how many columns there are, right? Because as you can see here, there's 3 columns. Similarly, if we go here, this is the first row. If we say the first row dot length, this would give us 1, 2, 3, 4. It would return us 4. And as you can see, we have 4 columns here. So that's how you'd get the number of columns, by saying that array of 0 dot length, or that array of 1, or however many rows you have dot length. So yeah, using the dot length method is extremely important when you're trying to traverse an array. So now that we know how to access, the length, right, of the rows and the columns, how do we put that together to traverse the array? Well, in order to do this, we have to use something called a nested for loop, which basically means it's a for loop within a for loop. So we have two for loops within, we have a for loop, like an overarching one, and we have a second for loop inside of it. That's what a nested for loop is. And one of the loops we'll be using to traverse through the rows, and the other one we'll be using to traverse through the columns. And as a result, when combining, right, the traversing through the rows as well as traversing through the columns, each individual, every time we go by one, we'll actually be accessing each individual cell. All right, and one way to do that is through doing this, right? So we use a for loop, right, for the row. So we say for int row equal to 0. Row is less than table.length. Once again, dot length of the entire array, right? Table.length, if that's the name of the array. That will give you the number of rows, right? So for row is less than, you can basically say for row is less than number of rows, right? Which is table.length, row plus plus, right? You increase it. Then we go into a second for loop. For int call equals 0, call is less than table of 0.length. Table of 0.length. And as you know, this will give you the number of columns, right? For a column less than the number of columns that are, column plus plus, and then now we're just populating it. So now we're just saying table of that row, not that column, is equal to row plus col. So table of, if it's 0, 0, table of 0, 0 is equal to 0 plus 0. If it's 1 and 2, it'd be table of 1, 2 is equal to 1 plus 2, which would give you 3. So if it's like if we get table of 1, 2 here, it'd be the first row here, the second column, first row here, table of 1, column of 2 is equal to row plus column, right? So that's 1 plus 2, that would give us 3, and so on. So this is one way of populating it, right? So we're choosing to populate each cell by the row variable here plus the column variable. That's how we're choosing to populate each cell. But obviously you can populate it however way you like for it to do it. And also one thing to keep in mind when you do create the array for the first time, right? You initialize it like this, it'll create an empty array full of zeros. And yeah, so the column loop is nested inside of the row loop. That's something to keep in mind. And the table, right, of row call accesses each individual cell value at that row comma column index. All right. So does anyone have any questions about how this works, right? Any questions about how the nested for loop works, or if you'd like me to elaborate, please text it in the chat or ask it out loud. Okay, so I guess now we'll move on. So now we have a 2D arrays coding demo. So now we'll be giving a coding demo of how to sort of implement all of this, right? So so as you can see, I have my Eclipse open. So the first thing we're gonna do is we're gonna go ahead and create our 2D array. So let's make it out of integers. So let's say integer array. Let's just call it table, right, as well. A new int. Now let's go and make the length a 5 by 4, as we mentioned earlier. And now we've gone and create this table. So now let's see what is in that array, right? Let's go see what's in that right now. So print it out. Now in printing 2D arrays out, you have to use something called the arrays dot deep to string. You have to go deep to the string, and then in here we pass in table. So make sure don't just type in table in here. Make sure you type arrays dot deep to string because it's a 2D array. If it was a 1D array, then you just say arrays dot to string. But since it's 2D, you have to say dot deep to string, and then you'll pass in the name of your array. Now if we go and print this out, we'll go and see that's full of zeros, right? This is 0, 0, 0, 0, 0, 0, 0, 0, 0, blah, 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 and so on. As you can see, each one of these square brackets indicates a row, right? So we have one row of square brackets, second row, third row, fourth row, fifth row, right? As we mentioned here. And then columns, right? Per row, we have 1, 2, 3, 4, right? Which tells us we have 4 columns. And as you can see, this is the 0th row, right? The first row here, 0th index. And the length of this row, right? If you look at it like a 1D array, that's why it works, right? The length of this row is 4, which is the number of columns. That's why it works. So if you see accessing each individual row as a 1D array. That's sort of how you would create one. So now let's go into populating it, right? So one way of populating it is to use the for loop, as we mentioned here. So to traverse it, like so. So let's go and create that right now. So we'll say for int I, let's say int row equal to 0. Row has to be less than table.length, right, as we mentioned. Row plus plus. Next, we'll go and create the next one. So for int column, column is less than table of 0.length, right? That's referring to the length of this right here, length of just this segment, which is 4. So that'll basically be less than 4. Column plus plus. And you can say table of 1. It doesn't really matter because then that'll just refer to this. Right? And it's still 4. The length of this thing is still 4. So it doesn't matter which one you refer to, but just table.0 is the safest one to go with. And then we can do something else. We can just say table of row column is equal to 5. So what this would do is so suppose we're at row equals 0, column equals 0, then I'll say table of 0, 0, which means the 0, 0 one, right, which is this one over here. Okay, yeah. So the 0, 0, it set this value to 0. That's how it works. So if row was 1 here and column was 2 here, then it's a table of 1 comma 2. That's 1 comma 2. This cell over here, it set this cell to 5. Right? Since we're saying every cell to 5. So now if we go and run this, let's go and reprint this now. After this loop, after everything's over, we now see everything is all 5s, right? Because we set every single index to 5. Now we can play around a little bit here. We're going to say, let's just set to row plus 1, right? So whatever the value of row is, it'll just set each cell to that number plus 1. So you'll get 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5. Now you must be wondering, why is it not 1, 2, 3, 4, 5, 6, 7, 8? That's because the row increments, right? If you look at the incrementing cycle of this, it'll only plus this, right, until the column satisfies table of 0.length. So until the column iterates 4 times in this scenario, after it iterates 4 times, then the row will increase. And since here I'm setting it to row plus 1, as you can see, it'll stay the row value for 4 values, then row will increment, and then it'll restart the column cycle and then do that again. That's why, as you can see here, it's 1, 1, 1, 1, because for the first 4, the row is not incrementing at all. It's just incrementing the column, not the row. So the row value is still equal to 0 here. And since we're doing row plus 1, it becomes 1. Same thing moving on. So the row only increments after the column reaches its limit. Then the row will increment to like the next number, so the next row, and then the column will reset at 0 and then go again. So that's sort of how this works. And then if you want to go to how we did over here, we can just do row plus column, and I'll just do something else. So here you can see it's 0, 1, 2, 3. That's because the column is constantly changing, but the row is staying constant, right? It's 0, 1, 2, 3 because the column is iterating, but the row is still staying constant, all right? Yeah, so that's sort of how you would implement a 2D array and traverse it in code in Java. Does anyone have any questions about this in general? Okay, Arnav, do you want to add anything, or would you like to move on?
I don't think I have anything to add. That was pretty good. So we can move on.
All right, so next, moving on to our last thing for today, which is bubble sorting algorithm.
All right, so next slide. Yeah, okay, so before we talk about bubble sort, I think we should start by talking about sorting in general and what really sorting is. And basically sorting is the process of sorting an array or array list in a certain order, whether this order is like an alphabetical order, reverse alphabetical order, lowest to highest numerical order, or like highest to lowest numerical order. And it just sorts an array or array list in any like particular way that you like specify or want to do. So there are basically many ways to sort, like many different ways to sort an array. And like there are thousands of algorithms or methods that have been like produced by people, where some are more efficient than others. And basically efficiency is the amount of time or number of processes a sorting algorithm takes. So if one array takes more time, like if one sorting algorithm takes less time than another, you probably want to implement that since that's more efficient. And you might be wondering like, hey, why does efficiency matter like for us? But efficiency really starts to matter when you like look at incredibly large amounts of data. Like for example, if you have a company like Facebook sorting billions of users, then you'd want to have an incredibly efficient sorting algorithm in order to make that process as quick as possible. And that's kind of like how Google is able to give you all of your results like sorted so quickly, is because they have like good and efficient sorting algorithms put into place. So that's basically what sorting is. It's just sorting data in like a particular order that you like specify with your code. Anyone have any questions or anything to add? All right, it looks like we have no questions, so we can move on to bubble sort now on the next slide. All right, so bubble sort is really not that efficient of a sorting algorithm, but it's really like quite simple and easy to understand as like a first sorting algorithm. And often this is like the first sorting algorithm that people learn, since it's like pretty easy to understand and it's like simple, although it's not that efficient. So
and also what Arnav means by not efficient is just the time it takes to run. In the end, like it still gets what you want to get. It still gets it done, but it's just a matter of how time goes. So that's what he means by not efficient.
Yeah, so for the sake of our example, we'll say that our algorithm wants to sort our data from like smallest to largest. So let's like take a look at how bubble sort really accomplishes this. So the first thing it does is it kind of has like the code design for a like bubble sort algorithm is it has a nested loop, and we just kind of covered nested loops with 2D arrays, but bubble sort utilizes a nested loop. And the outer loop, or like the first loop that you code, loops through all of the indexes in the array. So it actually doesn't loop through all of them, but it loops through like all of them -1. So it loops through the array size -1. And that's how many indexes it kind of loops through. And that's basically just the outer loop, and that it starts from 0 and goes to the index, like the length -1. And so for the inner loop, it basically loops through from 0 to the like it loops from 0, like the 0th index, to wherever the array is, like wherever you know that it stops sorting. So if we know what the inner loop does, it basically compares two elements. So the inner loop basically has its own index, right? And then if the element at the current index is greater than the element to the right of it, then it goes ahead and swaps them. And it does this, it continues looping through the entire loop, and it checks, hey, is this element greater than the one to the right of it? If so, then hey, let's swap this. And it does this like for the entire loop until the list is sorted, and then until like that particular element is in the right place. And then once that is done, it moves on to the next like iteration in the outer loop, and then it continues to repeat that process multiple times until the outer loop is like finished its cycle. And that's when the loop that's when the sorting algorithm kind of terminates, and that's when you know it's completely sorted. So basically we just repeat that for all indexes in the array. And now I think that was kind of probably kind of difficult to understand in words, but it's easier if we visualize it using a simulation. So let's go ahead and do that. If you want to give me screen sharing permission, yeah. All right. All right, okay, so we just talked about like bubble sort and how it kind of loops through the array in that order, but now let's look at it in a more like visual format. So if we go ahead and like say we have an array size that's 5, we can run this like program and kind of see how the code, like kind of how the algorithm works. So here we have like a completely randomized list of integers. As you can see, it's like completely randomized, and it's not sorted right now. It's not sorted in the order from like least to greatest, but let's go ahead and we'll take a look at the steps and processes it goes through. So the first thing it does is it looks at the element at this like 0th index here. So looking at the element at the 0th index, we can see that it's 590. So let's go ahead and look at the next step. So it basically compares this element to this element. And if we start the pass, we can see that it compares these two elements, 590 and 845, and say, is this element greater than this one? No, it's not. So so it's comparing them here, and then since it's not, it's going to move on to the next pass. And as you can see, it swapped these two elements. It swapped 710 and 845. Since this element was not greater than 845, it moved on to the next pass, and it swapped these two elements instead. And now we're going to go ahead and compare the elements at index 2 and 3. So hey, is 845 greater than 148? Yes, it is. So we'll go ahead and swap those. And then finally, is 39 greater than 845? No, it's not. So we'll swap those. And now we know that 845 is at its final place in the array, and that's basically like the final that's basically the last element in the array is in its final position. So they basically at the this is basically like when the outer loop kind of moves on to its next iteration. So this is one complete iteration of the outer loop. And once you complete one iteration of the outer loop, that's when you know that the greatest element will be in its final position or the end of the array. So now we can go ahead and look at the second pass. And looking at it, we're going to compare these two elements, 590 and 710. And since 590 is not greater than 710, we're not going to swap them. But now we'll go ahead and move on to comparing these two elements, 710, 148. And since this is greater than index 2, we'll go ahead and swap them. And we repeat that with these two elements as well and swaps them. And now we can see that 710, which is the second like largest element in the array, it's in its final position, and this is the second iteration of the outer loop. So now we kind of understand how the outer loop runs and how the iterations work. But now let's like focus more on the inner loop. So if we're looking at the inner loop is basically the loop that compares the elements with the elements. So the inner loop is basically saying, hey, is the element at index 0 greater than the element at index 1? No, it's not. So we'll go ahead and swap them, like we'll compare them and then we'll swap them. And that's basically what the inner loop does. It compares all of the elements up to there. And notice how if we continue running this simulation, we can see that after we ensure that 590 is in the correct place, we actually don't continue to compare these two elements. So since we already know that 590 is in its final position within the loop, we don't continue comparing all the way to the end of the loop, since that basically makes the algorithm more less efficient. So we basically terminate the inner loop at the position of when we know that the outer loop is sorted at that point. So if we continue the simulation, we can see it's going to compare these two elements finally, and then since that's done, we know that it's done sorting, and this is basically the completely sorted array. So that's kind of just a quick visual of how bubble sort really works. Now we can go ahead and take a look at the code for it. So does anyone have any questions about that or anything to add before we move on to looking at the code? Because I know that was a bit complicated, but hopefully the visual made more sense. So if anyone has any questions, feel free to type it in the chat or unmute yourself. All right, so it looks like we have no questions, so we can move on to the coding aspect of bubble sorts. So let's go ahead and open up Eclipse. All right, so I've actually written out the code for bubble sort beforehand, so it's a little less complicated, but let's go ahead and analyze the code from start to finish. So line 10, the first line of code, we simply just create a new array list of integers called list, and it basically just is a simple array list as we learned before. And this little section of code here basically fills up the list with random integers. So here we're basically saying the list is of size 10, and then we're just filling it up with the random integers. And if you're curious as to what math.random is, it's actually just a method within the math class of Java, and it basically just assigns a random number between 0 and 1, and then we're multiplying it by 100 to get like a random integer between 1 and 100. So this for loop basically just fills the array with integers between 0 and like 100. And in this line of code over here, it prints out the list before we sort it. So if we actually just go ahead and run the code right now, we can see that in the console over here, we have an array list of randomly generated integers that's not sorted, and it's just 10 integers from 0 to 100 that's printed out. All right, so now we can move on to the actual algorithm, which is this entire section of code. So let's take a look at it line by line. So this first line 22, this line over here, is basically just the for loop declarations for the outer loop. And this is kind of a loop that iterates through the array, like the entire array, as we saw in the kind of visual. This is basically just that loop that iterates through the entire array. So it starts at index 0, and then it goes into, and it continues until list.size -1. And if you're curious as to why it goes to list.size -1 and not list.size, and that's because if we actually went to list.size, we'd be looking at, we'd be like kind of looking at an index that's like out of bounds, and we don't want to do that. So that's why we go to list.size -1. And in addition, we don't want to like compare, we don't want to look at extra values that are already sorted. So basically, if we go back to the visual and look at like the very first pass, the reason that we do up to list.size -1 is that because we know that this is already going to be in the right place, so we don't need that extra iteration to kind of like, yeah, so we don't need that extra iteration because that's more inefficient. So then that's basically most of the outer loop, and the final part is we just do I++, and that's kind of just incrementing it so it can move on to the next index after the body of this loop is complete. Now we can move on to the inner loop, and this loop passes through the entire array up to the point that's already been sorted. So if you're confused as to what I mean by the point where it's been sorted, it's basically like looking back at the visual. In the second pass, the inner loop is not gonna go up till index 4. It's actually just gonna look at indexes 0 to 3, since index 4 is already sorted. So it's just gonna look at 0 to 3, and that's basically just what I mean by up to the point that's already been sorted. And again, if we look at the loop, we start at 0, which is the 0th index, and then we go to list.size -i -1. And when we say list.size -i -1, we're basically just saying that, yeah, again, that's just basically what it means. Like, that's basically just when the loop like knows that it's sorted. So if it goes past that, then we already know that that point is sorted, so we don't look at that for efficiency. So that's kind of just what this section is. And then again, we just say J++, and that's like incrementing the inner loop for continuing to like loop through the indexes. And then we can move on to the body of the inner loop. So we have this entire section over here, and we have this if statement, and that like you're gonna be comparing two values in like almost every sorting algorithm. So this is basically where we compare the values at j and j+1, which is the looking back at the visual, we can see we're comparing like j and j+1 would basically be like these two values, so it'd be like 0 and 1, and then so on and so forth. It would be like 1 and 2, and that's just what j and j+1 is. So the if statement basically just compares those two values. So it says, hey, if list.get j is greater than list.get j+1, then let's go ahead and swap those two elements. And again, the reason we're able to swap them is because although you can't, if this were an array, you would still be able to swap them. And just to clear any confusion, in a normal array, you can't change the size, but you can still set and swap elements after the array has been created. So basically, if the index at j is greater than j+1, we're just going to go ahead and swap these elements using this code. And the way we actually swap them is we have a temporary variable which is, and in that temporary variable, we store list arc at j. And then after that, we say, we set the value at j to whatever the value at j plus 1 is. And that's basically kind of just swapping them. And then finally, we set the value at j plus 1 to our temporary variable. And our temporary variable is basically just the value that we found at j. And just note that we only execute this code if the value at j was greater than the value at j plus 1. And that's basically like the only time we'd be looking at that if statement. And that's basically just one pass of the inner for loop. And then after that's executed, we continue to loop through this entire loop. And note that we don't go to the next, like we don't increment the outer loop until this loop is complete. So only after the inner loop is done with whatever it needs to like get done, after that only we can move on to like moving on to the next index at the outer loop. And that's basically just what like a simple bubble sort algorithm is. And there are many different ways to implement this. Like you can compare, if you wanted to like make a list like going from lowest to highest, you simply just change this from a greater than to less than. And like that's basically just a simple bubble sort algorithm. There are many ways to sort this. You can start by sorting from the right side to the left side instead of from the left side to the right side. In this example, we started by sorting the left side first, or the right side first. As we can see in the visual, the right side is sorted first, but you can actually make it so that the left side is sorted first by changing the loop. But for the purpose of this demonstration, we're looking at a more simple algorithm where we compare, where we make it from least to greatest and sort the right side first. So let's go ahead and run this code. And if we run the code, or actually let's just look at the rest of the code. After the loop is like done, we go ahead and print out the thing we print out the array list at the end. So if we run the code, we can see that in the first line, we have a completely randomized array list of integers. And as you can see, it's just completely randomly generated. It's a list of 10 integers. But then after we go ahead and run the bubble sort algorithm, we essentially sort the entire list. So if we look at it now, it's sorted from least to greatest integer value. So it's, if we look at it, it's like from least to greatest, so it's 4, 5, 12, 17, 20, 26, 59, 65, and then 65 is actually repeated twice. That's just random, and 78 finally. So that's basically just the loop, sort of like the algorithm sorting the array, and that's when we know that it's like completely sorted. And the algorithm actually doesn't matter if you have two of the same value in the algorithm, since we're only looking at, hey, if j is greater than j plus 1, only then we swap it. So it actually doesn't matter if we have two of the same value, the algorithm still works like the same way. So that's basically just like the bubble sorting algorithm. It's kind of complicated to understand initially, but hopefully the visual and the actually like studying the code line by line made a bit more sense. So if anyone had any questions or like anything to add to that, please feel free to unmute yourself or ask a question in the chat. All right, so it looks like we don't actually have any questions. If you have anything to add on to that.
No, I think that was great, Arnav.
All right, okay, so we can move on to the rest of the, yeah.
All right, so that basically concludes our session for today. So you can go ahead and access the worksheet at intermediate worksheet 7, TinyURL, and submit it at the same submission link. So yeah, thank you all so much for joining us for day 7 of Bay Tutors, Intermediate Advanced Coding Camp, and we look forward to seeing all of you on day 8.